So we understand how we can find a specific time till the moment of prediction when we say now it's the fourth revolution, till the time we'll hit the diamond and drop into the rotor. We know that this wheel is tilted, so 2 factors of 4 are okay. Now we need the third factor. Before the ball when the rotor is starting to moving, when the ball is releasing, we must time the rotor movement. In other words, the numbers, how fast they are moving. The purpose of it is that we must know how many seconds, for example, a rotor will make a whole revolution. For example, from this number to go to here again, one whole revolution, how much time? We can have a rotor that will do 1, 2, 3, 4 seconds. We call this rotor 4-second rotor. Only it can do 1, 2, 3 seconds. General, the slower the rotor will be, the best results we will have, because if for example the ball will hit this diamond, as I told you, we can take advantage of it. So some people are counting rotor by this way. They have a timer with them, with vibration or something like this, because they do not want the casino to spot them, and they count, for example, from here when a number is passing from here, or we can do any place. There is no particular reason for here, but we will almost all do from here because it's more visible in the casino. So they count 1 second. When this number will go 1 second here, they are doing what? They're waiting for the fourth revolution. They're watching the revolution when the ball is passing here, and they're watching what number is under the diamond. Then they remember this number, and also they remember where the number of the timing of the rotor was in, for example, 1 second, or some of them they do 2 seconds. So when we know, for example, that this number in 2 seconds, let's say, was 1 second, 2 seconds here, we just keep in mind that particular speed. We keep that speed, and we are observing when the ball is passing from the dominant draw point at the time of the fourth revolution. We are watching the number under the diamond. When the ball is making the fourth revolution and it's hitting into the rotor, this is the other number that we must have in mind. So look, we must have in mind the number that went for 2 seconds at which place of the rotor, which place, 12 o'clock, 1, 2, 3, 4, 5, 6, 7. For example, here is 7. Okay, so the visual ballister, keep in mind that when the rotor was at 7 o'clock, at the fourth revolution, this number was down of a diamond. And when the ball is hitting the diamond and hitting into the rotor, they are watching a third thing, the strike point number. So they say, for example, this was my number under the diamond at the fourth revolution, and the strike point, for example, was, let's say, here. And all this with rotor speed, when in 2 seconds went here. So what they do? They know that with this particular rotor speed, the observation point, in order to predict the strike point, will be this distance. Okay, let's say it was this number, the strike point. So they count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here was the prediction under the diamond, the observation point. I said 12, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. So when the ball is going in a particular time here, when the rotor is going here, when the ball will pass this diamond, they will immediately, when the ball is going here, it will look there. This is almost all visual ballistic systems related on, and it's a universal thing. It's not that one visual ballistic have this thing and we're exposing it right now. So in the other spin, if the rotor is going, for example, a little faster than here, the rotor, they count, okay, and the number was not here now, was here in the spin. So we have some pockets more. Depending on the time that they are counting, the rotor must put more hours of observation in order to predict the strike point, because a rotor now is faster. So it will not be the observation point again here. So every time the rotor is faster or slower, they are moving these observation points and take the predictions. In the end, they're adding the average jump of the ball, the scatter in other words. So if they see that scatter is, for example, 9 pockets, they say the observation point in this particular speed was here. Adding 9 pockets, it will be here. So they will immediately look here, for example. Or if the rotor is a little faster and the observation point is not here, but it is here, they will add 9 pockets from there, and now the observation point to take the prediction will not be here. No, sorry, I said faster. So the observation point will move forward, because this is a clockwise direction of the ball. If it is an anti-clock direction, you are doing minus in order to find the observation point if the wheel is faster and the ball. So as you understand, a lot of factors are including in the visual ballistic prediction. You must find the right revolution. You can float. You must know exactly from here in some seconds where the rotor was in order to look at the right observation point. You can do small mistakes there. If you are a very trained visual ballistic player, you can do small mistakes, but small mistakes are just making the advantage less. You are losing some advantage, and this is not good. You must find also the average scatter and make it plus into the observation point. So one mistake you can do, float in a revolution, not predict the right revolution. Second mistake, you can do mistake with the observation point. Third, maybe you can do a little mistake in adding the scatter. The roulette computer are making all these things automatic. When you click the button, all these things are stable. You can float in very little spins the revolution. For example, a visual ballister in 100 spins, if all spins will hit this diamond, it can be wrong at 40 spins. From the 100, it can be wrong at the 40. The roulette computer maybe will do a mistake in 3 or 4 over 100. And maybe this will be for a bad clocking, for example, that we made. I will continue in the third part, because I don't think that YouTube would allow me to record more in this video.